Like I said, we are still out of the same note packet. Okay, so it looks like this, and we are on pages 3 and 4 today. So like I said, we've dealt with imaginary numbers, simplifying those, and then we dealt with the square root method where we can have imaginary or real solutions. When we combine these two ideas, okay, when we combine real numbers and imaginary numbers, we get what's called a complex number, okay? And a complex number is the addition of a real or imaginary number, okay? It's represented in the form, so this is like a generic form, a plus bi, where a represents a real number. So any number that you've seen in a coordinate plane before, any number that you've seen on a real number line, that's our a piece, that's that real number. The b represents the imaginary part. So it's a number times I, it's an imaginary number, something that we've seen before, something that we've dealt with simplifying, okay? As you can see here in a couple of the examples, so we're going to deal with the operations of these complex numbers today. So we'll talk about subtraction and addition. We'll talk about multiplication and division. But if you just kind of reference down here, these are what's called complex numbers. So I have a real number like 3, I'm adding a 6i. I have a 4, a real number, I'm subtracting an imaginary number 2i. So this is what it's going to look like each time, that combination of a real and imaginary number, okay? A lot of the same algebra rules apply to imaginary numbers as we've seen with variables and things like that, okay? So the I shouldn't really throw us off, okay? There's two kinds of examples that you're going to see with sum and difference, all right? And this is probably the easiest of our operations. So we'll have an example where we have a complex number adding to that another complex number. When there is an addition sign in between, okay, we can think about just dropping the parentheses, okay? So I can say that this is 3 plus 6i plus a 4 minus a 2i. So I don't have to worry about the parentheses anymore. I drop those and I just kind of rewrite the same line there, but it might help me with understanding how I can combine like terms, okay? Just like when dealing with variables, you can combine things that don't have variables attached and things that do. Well, it's the same thing here. I can only combine real numbers with real numbers and imaginary numbers with imaginary numbers. So if I'm going through here and I'm adding or subtracting, I know that I can combine the 3 and the 4. That's going to give me 7 because it's 3 plus 4. And then I can combine my imaginary numbers, 6i and negative 2i. And what's that going to give me? 4i. And then 7 plus 4i is going to be my solution when I add those two complex numbers. Now, one thing that I want you to keep in mind, our complex numbers are in the form a plus bi. That real part is always going to come first. So 4i plus 7, we want to get away from ever writing it like that. We always want to put the real part first. So 7 plus 4i, okay? Any questions about number 1, just adding complex numbers? Pretty easy stuff, just combining like terms. The difference when we're subtracting, so you see here number 2, I have 3 minus 2i minus 2 minus 3i, okay? What you might want to note here is that when we are subtracting, we need to distribute, okay? So a little note that you might want to make for yourself is that when we subtract, we distribute. So what that means is, comparative to when we're adding, notice we have the subtraction sign here. Well, the 3 minus the 2i is going to stay the same. But I need to distribute that negative into each term in my second complex number. So to the 2 and to the negative 3i. Okay? And when I do that, what's going to happen to each of those terms? Exactly. So the signs are going to change. Instead of a positive 2, I'm going to have a negative 2. And instead of a negative 3i, I'm actually going to have a positive 3i. So that's something that we need to be really careful with when we're subtracting complex numbers, that we distribute that negative into the second term. Okay, because it's going to change the signs. If you were just to drop the parentheses, the way that you would simplify this isn't going to be the right answer. So make sure that we distribute when we subtract. So make sure you make a note of that. However, after we do that, we can combine like terms the same way as we did before. So what two terms am I going to combine here? Or what groups of terms will I combine? Good. So I have the 3 minus 2, the negative 2i plus the 3i. 3 minus 2 will give me 1. Negative 2i plus 3i will just give me a positive I. And this is how I'm going to leave my answer for this particular problem. Okay. Any questions about adding or subtracting complex numbers so far? So when we add, we just drop the parentheses, combine terms. When we subtract, we distribute that negative first, and then we can combine like terms the same way. Everybody good? Okay. One thing I do want to note, we're going to do some skipping around. We'll go a couple problems for each. But whatever we don't get to, you can use as a review for yourself. Okay. Not skipping them over for any particular reasons, just kind of for the sake of time and also to show a variety of questions. We'll transition now into product. So product obviously means we're doing multiplication. All right, we're going to look at numbers 1 through 5. And the reason that we're going to do that is each problem has its own kind of unique view here. So like in number 1, I'm multiplying a real number times an imaginary. Number 2, I have an imaginary times an imaginary. Number 3, I'm distributing a real into a complex. 4, distributing an imaginary into a complex. And then 5, I have a complex times a complex. So these are all the kinds of questions that you might see when dealing with a product, okay? A lot of the same algebra rules apply though. So what do we think our answer should be for number 1? If I have 2 times 3i, 6i, right? Just like if it was 2 times 3x, you would get 6x. 2 times 3i, you just multiply those coefficients there, and we get 6i for an answer. Okay, so real times an imaginary, I can just tag that I along. Nothing too strenuous there. What do we think the answer should be for number 2? So I have 2i times 15i. I squared, good. So it's going to be 30. Again, I just multiply those coefficients. And then I times I is going to give me I squared. But the biggest thing that we need to take away, especially when multiplying, we'll see it again later when we divide. What do I know that I squared is equal to? We talked about it earlier on this week. Because we don't want to leave any exponent.
It's equal to -1.
Exactly, good, nice job. It's equal to -1. We don't want to leave any imaginary numbers with exponents. So when that's the case, what we would do here is wherever we see an I squared, we're going to plug in -1. We're just going to substitute that in. So I have 30 times -1, bless you. 30 times -1 or just -30. So on a homework or a test or quiz, if you were just to leave it as 30i squared, that's not going to be the correct way to simplify this. Okay. So the note packet on the left is what we're doing right now in class. It's also in the packet to the right if you want that to review. That's what we did earlier on in the week. So you just take that. Like I said, on the homework or test or quiz, if you leave it as 30i squared, you'll get partial credit, but not full credit. It's technically -30 for the final answer. Okay. Any questions about number 2? Making sure that whenever we see an I squared, we go ahead and simplify that. Okay. Number 3, I have 3 times 2 minus 7i. So I have a real number times a complex number. What do you think I'm going to have to do with that 3 that's out in front of my complex number there? Distribute. So every time that we see parentheses, right, a lot of times we think, okay, I have to distribute into that. Same thing applies here. So I'll take that 3, multiply it by the 2. I'll take the 3 and multiply it by the negative 7i. Three times 2 gives me what? 6. 3 times negative 7i gives me what? Negative 21i. Can I combine those at all? No, right? I have a real number, an imaginary number. This is how I'm going to leave my answer. And again, just to reiterate a point earlier, I'm going to write it as the real number first, followed by the imaginary number. Okay. Question here. So an I next to it, yeah. So don't confuse it with like a variable like X or Y. Anytime it's I, that's symbolizes an imaginary number, yeah. Yep. Any other questions? That's all right. It's just a plus bi. So that's what a complex number looks like. All of these that we're dealing with are going to involve complex numbers. So the a is just a real number. And then like you said, the bi, so it's a number times I. So that's the imaginary part. Yep. Okay. Let's take a look at number 4. Now, instead of having a real number times a complex, I have an imaginary number times a complex. Not really going to change my method here and how I would simplify. What should I do with that 2i? Again, right? We distribute. So I'll do 2i times 4 and 2i times 5i. What's 2i times 4 going to give me? 8i. What's 2i times 5i going to give me? Positive 10i squared. But what do I notice about that? Can I simplify that further? Okay, so there's exactly. Good job. So anytime that we see an I squared, I know that becomes 8i plus 10 times negative 1. I just substitute in from this note up here, if you haven't made it already, I substitute in a negative 1 wherever I see an I squared. And then this becomes negative 10 plus 8i. Okay. Any questions about number 4?
Why'd you put 10 in front of the 8i?
Okay, good question. So it relates back to the original note that when we write our answers as complex numbers, we want to make sure that the real term comes first, followed by the imaginary. So notice that when I simplify, the 10 times the negative 1 gives me a real number of negative 10. I still have the 8i there. That's my imaginary. The negative 10 is my real. So I want to write the real first, followed by the imaginary. That's why I put the negative 10 out in front.
Okay, thanks.
So that's how we want to write all of our answers. Notice like I have the 6 minus 21i, 1 plus I, 7 plus 4i. It's always going to be in that form. Okay. Number 5. This is a little bit more of a unique example because now I have a complex number times a complex number, okay? But what we do to simplify this is something that we've seen a lot in algebra and a lot of our other classes. We use that FOIL method. So whenever you see complex times a complex, you FOIL. Remember that FOIL stands for first, outer, inner, last. So somebody walk me through how I might apply that method to this example here. So I'll do 3 times 5 and I get 15. Six I, good. Good, awesome job. And exactly how we did that is how you should go through this process, right? Don't try to do too much at once. Don't try to do a lot in your head and try and combine things and simplify. Go through, multiply all the terms first, and then write down that line. Then you can go ahead and simplify from there, okay? So what I would do is try and combine like terms, maybe substitute values if you need to. What can I combine here in this line? The 20i and the 6i. And I'll have 15 plus 26i. I have an 8i squared. What does that become? Good. It's going to become -8. Now I'm just going to show that process where I substituted it in just in case we don't know where it comes from. But I squared is -1. So as you said, 15 plus 26i now becomes -8. And I can combine a little bit further, right? What should my final answer be? Good. 7 plus 26i. Okay. So a little bit more of a process here when we are foiling, but take it step by step. Multiply all your terms together, combine like terms, plug in values. A lot of times when you multiply an imaginary and imaginary, pretty much every time, you're going to get that I squared. So you know that that's going to become the -1. Combine like terms again, write your answer as the real part followed by the imaginary. Okay. Any questions on this first page here, just doing addition and subtraction or anything multiplication wise? See that there's a variety of questions that you could have, but all the processes follow very similar algebraic processes we've seen before. It's just a matter of applying them now to imaginary and complex numbers. Everybody's good? Okay. The trickier part, or at least the part that's a little bit more of a process, is when we divide complex and imaginary numbers. Okay, when we're doing division of complex numbers. Okay, so this is the last page of the notes if you're following along. That note there says we treat division problems of imaginary or complex numbers like simplification problems. What we don't want, and that note there that I'm going to underline here, is an I in my denominator. So I can't leave a fraction with an I in my denominator. I need to get rid of everything that's complex or imaginary in my denominator. Okay. And there's two situations or two kind of processes that we need to remember for division. If there is an imaginary number in my denominator, so you see here, I have an example, 3/2i. 2i is an imaginary number. If it's just an imaginary number in my denominator, what I do to get rid of it is multiply the numerator and denominator by I, and then I simplify. I over I, good question. So I was gonna show that there in a second. You're multiplying both the top and bottom, the numerator and denominator, by I when your number is an imaginary number in the denominator, okay? So we have this example here. I have 3 over 2I. I'm going to multiply top and bottom by I. So it's going to be I over I. And that would be your first step when you have the division of a complex number and your denominator is imaginary. And we're going to go through some examples. I'm not going to simplify that specific one right now, but we'll go through a couple examples here where we see the difference in the process. Okay. When my number in my denominator is a complex number, the process is very similar. So I'm going to multiply the numerator. I'm going to abbreviate numerator and denominator this time by what's called the conjugate. And then I'm going to simplify. When there is a complex number in my denominator, I multiply the numerator and denominator by the conjugate, and I simplify. So the first question that you have to ask yourself is, what's in my denominator? Is it an imaginary number or is it complex? Then you work to say, okay, if it's imaginary, multiply by I over I. Complex, I multiply by what's called the conjugate. Now, a lot of us are probably thinking, well, what is a conjugate? What does that mean? What do I multiply it by? The conjugate, and I'm going to use this example to help us, is the same terms. So instead of 2 plus I, it'll be the same terms. I'll have a 2 and an I, but they're separated by the opposite sign. So I'm going to multiply top and bottom here. Instead of 2 plus I, it'll be 2 minus I. So again, the conjugate is the same terms as we see there. We're just changing the sign. And the reason that we do that, and we'll see how it plays out in some of our examples, is because we're trying to get rid of the I in the denominator. Notice that I'm multiplying two complex numbers. I'm going to have to FOIL, and there's going to be some simplifying there that will get rid of my I. Okay. Any questions so far just about the process of what we're doing here with division? Everybody's good? Okay. So let's take a look at a couple examples. For each of these, I'll do kind of like the first one on my own, and then we'll talk about the second one, okay, as more so as a group. So number one here, I have 3 over 2i. The first thing that I'm going to do is think to myself, what's in my denominator, right? I recognize that we're doing division. What kind of numbers in my denominator? Well, I have a 2i. I'm not adding any or subtracting anything from that. That's just an imaginary number. So what I'm going to do is multiply top and bottom by I. Multiplying fractions, I can just multiply straight across. So in my numerator, I'll have 3i from 3 times I. In my denominator, I'll have 2i times I, or 2i squared. My numerator can't simplify any further. I'll leave it as 3i. My denominator, though, I know 2i squared is the same thing as 2 times -1, which is just -2. So I'm simplifying. I'm making sure I have no i's in my denominator, which I do. See if I can maybe simplify the fraction at all, which I can't. This is my final answer. So in its simplified form, I have 3i over -2. Okay. Any questions about the first example? Let's do number 2 together. I have -15 over 3i. What kind of numbers in my what kind of number is in my denominator? Is it an imaginary number or is it complex? Imaginary. So what do I have to multiply top and bottom by? I. -15 times I is going to give me what? -15i. Somebody from home, help me out with this one. 3i times I is going to give me what number?
3i squared.
3i squared. Does my numerator simplify at all, or does it kind of just stay the same? Stays the
You
same,
can
right?
simplify to -3, or the denominator at least.
Exactly. Good. So that was my next question. And I was going to get somebody from home to help me. Notice that 3 times -1, right? I simplify the I squared, or I plug in a -1 wherever I see that, is going to give me -3. Now, something that's a little bit different about this example comparative to the number 1, we think we can simplify this a little bit further. Over 1, is that what you said? Yeah. Okay. So, yeah. Right, exactly. Okay. So I can simplify this a little bit further. I have -15 over -3. Well, negative times a negative is going to give me a positive. And the 15 divided by 3 is going to give me a 5. And the I just tags along from the numerator. My answer is 5i. So you said the same thing. You recognize that -3 goes into -15 5 times, and the I just tags along. So if you can simplify a fraction, make sure that you go ahead and do that, okay? There's going to be times where you can. Obviously, in example 1, there was a situation where we couldn't. I just left it as is. But if you can get it down to this point, make sure you do that. Any questions about number 2? Okay. Again, I'm going to do number 4 a little bit more on my own. Number 5 we'll do as a group. Number 4, I'm going to ask myself the same question, though. I recognize that there's division. I'm going to ask myself, okay, well, what number is in my denominator? Do I have an imaginary or complex? Notice that I have a complex number this time. So I have 2 minus I. And that triggers me to say, okay, well, I have to multiply top and bottom by the conjugate. So I'm going to start by doing that. 2 minus I. Instead of that, my conjugate is going to be 2 plus I. So I keep the same terms. I just change the sign. And whatever I do in the denominator, I have to do in the numerator too, multiplying top and bottom by that conjugate. Now, something that I would do just to help you visually with this problem is to go ahead and rewrite this, but include some parentheses. So I have 15 times 2 plus I over 2 minus I times 2 plus I. Because now, hopefully, you're able to see what you might have to do in both the top and bottom, right? In the numerator, I have that 15 times the times that complex number. I'm going to distribute. And my suggestion to you would be to take everything step by step. Don't try to do too much at once. Okay. Well, when I distribute, 15 times 2 is 30. 15 times I is 15I. In the denominator, I have a complex times a complex. That means I'm going to have to FOIL to simplify. Okay. So I'll do 2 times 2, that gives me 4. 2 times I gives me a positive 2I. 2 times negative I gives me a negative 2I. Negative I times a positive I gives me negative I squared. Remember that when I'm foiling, I'm multiplying. So be careful about adding and all that stuff. You're multiplying when you FOIL. Any questions about what I've done so far? Now what I'm going to do is combine like terms. In my numerator, it actually stays the same. Right? Nothing combines there. In my denominator, the 2I and the negative 2I are going to cancel. This is always going to happen when you are simplifying by dividing, right? We're trying to get rid of the i's in my denominator, so they're going to go away. And I'm left with 4. Well, negative I squared is the same thing as negative 1 times the I squared becomes a negative 1. Well, negative 1 times negative 1 becomes a positive 1. When I add that, I have 30 plus 15I over 5. Any questions about how I got to that point with any of the simplifying? Yeah. It's technically negative 1. So that negative sign there, it's like negative 1 times I squared. Well, we know I squared is negative 1 also. So it's like negative 1 times negative 1, which gives you a positive 1. That's how I got the plus 1 there. What's that? Exactly. So good insight. So I have 30 plus 15I all over 5. Notice that 5 goes into each of those terms evenly, right? So I would do 30 divided by 5, which gives me the 6. 15I divided by 5 gives me the 3I. I can't combine those, but this is my most simplified form of that original expression there. Okay. Any questions about what I did here? Okay. I'm gonna give myself some space. Let's do number 5 as a group. First question. What kind of number do I have in my denominator? Is it imaginary or is it complex? Complex. So I need to multiply by the conjugate. How about somebody from home? Help me out with this one. What's the conjugate of my denominator? If I have 2 plus 3i, what's the conjugate?
2 minus 3i.
2 minus 3i. Good. Multiply top and bottom by that. Again, my suggestion would be to rewrite the numerator and the denominator, just so you're aware of what you're doing and what operation's taking place. One thing that we should notice as you're copying this down that's a little different is that I have a complex times a complex in the numerator and denominator. So there's going to be quite a bit of work that I need to show here in order to simplify, because if I have a complex times a complex, as we've seen before, that should trigger that we need to FOIL. So I got to FOIL not only in the denominator again, but in the numerator as well. Okay. Everybody with me so far? Everyone's good. When I FOIL in the numerator, I'll have 5 times 2, which gives me 10. 5 times negative 3i gives me what? When I do the outer terms in the numerator, so 5 times negative 3i, negative 15i. 2 times negative I gives me negative 2i. And then negative I times negative 3i gives me what? Positive 3i squared. So be careful about sign changes too, right? Positive times negative gives you a negative. Negative times negative gives you a positive. Positive times positive obviously is positive as well. Take it step by step. Don't try to do too many things at once, right? I just took care of my numerator. I'm going to move on to my denominator. 2 times 2 is going to give me the 4. 2 times negative 3i gives me what? Negative 6i. 2 times positive 3i gives me positive 6i. And then positive 3i times negative 3i gives me what? Negative 9i squared. Good. Take a second to kind of catch up and jot some of that stuff down. All we did in that process was FOIL. So I multiply the first terms, the outer terms, the inner terms, and the last. And I did not do any simplifying yet. Okay. So like I said, don't try to do too many things at once. Just multiply all of your terms together first and then work from there. Okay. When I combine like terms in the numerator, what do I get? What's a simplified form here of my numerator? (10 minus 17i plus 3i squared). Now, I know I squared is -1, so I'll have 3 times -1, which is -3. So I kind of did a couple steps there at once. Somebody from home, help me out with my denominator. How would the denominator simplify? Somebody from home, any ideas? My denominator, how's that going to simplify there? The 4 minus the 6i plus the 6i minus 9i squared.
Well, the 6i, negative 6i and the 6i would cancel out.
Right.
And then after that, you would simplify the 9i squared, which would simplify to a positive 9.
Exactly. Good. It'll simplify to a positive 9. Then I'll have 10 minus 3 is going to give me 7 minus 17i. 4 plus 9 will give me 13. And the last thing I want to do is check to see if I can simplify that further, similar to what we did over here, the 30 plus 15i over 5. I knew that my denominator went into each of those evenly. Not the case here. So this is my final answer. Okay. Any questions about that example there? All right, so that's the bill. Your homework for tonight, very quickly. So